the electrical inspector's interpretation of the code is likely correct. NEC 250.32 requires a ground rod for a separate structure, which is defined as a structure not attached to and not serving as an extension of a main building or other structure. In this situation, the 6x6 timber supporting the remote weatherproof panel could be considered a separate structure since it is not attached to or serving as an extension of the pool building. NEC 250.104 requires that metal enclosures for electrical equipment be bonded to the grounding electrode system. However, NEC 250.104 A5 specifically exempts electrical enclosures that are part of a listed assembly from this requirement. If the panel enclosure is part of a listed assembly, it may not need to be bonded to the pool bonding conductor. Consider these recommendations. Firstly, consult with the manufacturer of the panel assembly to determine if it is listed and requires bonding to the pool bonding conductor. Secondly, review the site conditions to confirm that the timber support meets the definition of a separate structure. Thirdly, consider using a different type of enclosure that is not part of a listed assembly, or bond the enclosure to the pool bonding conductor if possible. Fourthly, if necessary, install a ground rod as required by NEC 250.32. Several additional considerations apply. Firstly, the electrical inspector's interpretation may vary from one jurisdiction to another, so it is important to consult with local authorities for specific requirements. Secondly, the safety of the installation should be the primary concern. If there is any doubt about the proper grounding method, it is always best to err on the side of caution and follow the inspector's requirements. To further clarify the requirements and provide a more detailed explanation, let's delve deeper into the relevant sections of the National Electrical Code. NEC 250.32 specifically addresses grounding requirements for outbuildings and separate structures. The primary purpose of this section is to ensure that any structure that is not directly connected to the main building's grounding system has its own independent grounding system. This prevents potential differences in ground potential between the main building and the separate structure, which could lead to dangerous voltage gradients and increase the risk of electrical shock. In the context of a swimming pool, where water and electrical equipment are in close proximity, it's extremely important to minimize any potential shock hazards. The code defines a separate structure as one that is not attached to and does not serve as an extension of the main building. The key here is the independence of the structure's use and support. If the 6x6 timber is solely supporting the electrical panel and is not physically connected to the pool structure or any other building, it's likely to be considered a separate structure. This determination depends on the specific details of the installation, so a thorough on-site assessment is crucial. When a structure is deemed separate, NEC 250.32 mandates the installation of a grounding electrode system. This typically involves driving a ground rod into the earth near the structure and connecting it to the panel's grounding bus. The ground rod provides a direct path to earth for fault currents, helping to quickly trip circuit breakers and minimize the duration of any electrical faults. The specific requirements for the ground rod, such as its size, depth, and material, are outlined in other sections of Article 250 of the NEC. In addition to the ground rod, the code also requires a grounding electrode conductor to connect the grounding bus in the panel to the ground rod. The size of this conductor is determined by NEC Table 250.66, which is based on the size of the ungrounded conductors supplying the panel. This ensures that the grounding electrode conductor is capable of safely carrying any fault current back to the grounding electrode. Now let's consider the exception mentioned in NEC 250.104, A5, which pertains to listed assemblies. This section of the code addresses the bonding requirements for metal enclosures that house electrical equipment. Generally, the code requires that all metal enclosures be bonded to the grounding electrode system to provide a lower impedance path for fault currents. However, NEC 250.104 A5 provides an exception for enclosures that are part of a listed assembly. A listed assembly is a pre-manufactured unit that has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories Incorporated, Intertek, or Canadian Standards Association. These assemblies are designed and tested to ensure that they meet specific safety standards, including grounding and bonding requirements. If the electrical panel enclosure is part of a listed assembly, the manufacturer's instructions will typically specify whether or not additional bonding is required. In some cases, the assembly may be designed in such a way that the enclosure is already adequately grounded through internal connections, and no additional bonding to the pole bonding conductor is necessary. However, it's crucial to carefully review the manufacturer's instructions and their listing information to confirm this. The listing information will usually be found on a label or nameplate attached to the assembly. If the manufacturer's instructions are unclear or if there is any doubt about the proper bonding method, it's always best to consult with the manufacturer directly or seek guidance from a qualified electrical engineer or inspector. In the specific scenario described, the inspector is questioning whether the panel enclosure should be bonded to the number 8 solid pole bonding conductor. This conductor is typically installed as part of the equipotential bonding system for the pole, which is designed to minimize voltage gradients in and around the pole area. The equipotential bonding system connects all metal parts of the pole structure, including the reinforcing steel, metal piping, and any metal equipment associated with the pole, such as pumps and filters. By bonding all of these metal parts together, the equipotential bonding system ensures that they are all at the same electrical potential, reducing the risk of electrical shock. If the electrical panel enclosure is not part of a listed assembly, it should typically be bonded to the pole bonding conductor to maintain the equipotential bonding system. However, if the enclosure is part of a listed assembly and the manufacturer's instructions do not require additional bonding, then it may not be necessary to bond it to the pole bonding conductor. It's important to note that the inspector's interpretation of the code may be influenced by local amendments or interpretations. Some jurisdictions may have specific requirements for grounding and bonding electrical equipment near swimming pools that go beyond the minimum requirements of the NEC. Therefore, it's crucial to consult with the local electrical inspector to determine the specific requirements in that area. To provide further clarification, let's explore some additional aspects related to grounding and bonding in the context of swimming pools. One important consideration is the type of wiring method used to supply power to the electrical panel. If the wiring method includes a metallic conduit or cable armor, it's important to ensure that the conduit or cable armor is properly grounded and bonded to the grounding electrode system. This provides an additional path for fault currents and helps to minimize voltage gradient. Another important consideration is the location of the electrical panel relative to the pool. The NEC specifies minimum distances that electrical equipment must be located from the pool to prevent shock hazard. The specific distances vary depending on the type of equipment and the voltage level. It's crucial to ensure that the electrical panel is located at least the minimum required distance from the pool. In addition to the grounding and bonding requirements, it's also important to follow all other applicable electrical safety codes and standards. This includes using ground fault circuit interrupter protection for all receptacles located near the pool, as well as ensuring that all electrical equipment is properly installed and maintained. Ground fault circuit interrupters, or ground fault circuit interrupter receptacles, are designed to detect small ground faults and quickly trip the circuit, preventing electrical shock. They are typically required for all receptacles located within a certain distance of the pool, as well as for any receptacles that serve pool equipment. Proper installation and maintenance of electrical equipment are also essential for ensuring electrical safety. This includes regularly inspecting the equipment for damage or wear, replacing any damaged parts, and ensuring that all connections are tight and secure. By following all applicable electrical safety codes and standards, it's possible to create a safe and enjoyable swimming pool environment. To summarize, the grounding and bonding requirements for electrical equipment near swimming pools can be complex and depend on a variety of factors, including the type of equipment, the location of the equipment, and the specific requirements of the local jurisdiction. It's crucial to carefully review the NEC, consult with local authorities, and follow the manufacturer's instructions to ensure that all electrical installations are safe and compliant. Consider this real-world example: a homeowner is installing a new pool in their backyard. They want to install a small electrical panel near the pool to power the pool pump, filter, and lighting. The panel will be mounted on a 6x6 wooden post that is not connected to the house or any other structure. The electrical inspector tells the homeowner that the wooden post is considered a separate structure and that the panel must be grounded with a ground rod. The homeowner is unsure if this is correct, as the panel is relatively close to the house and the pool is already bonded. In this case, the electrical inspector's interpretation is likely correct. Even though the panel is close to the house and the pool is bonded, the wooden post is considered a separate structure because it is not attached to the house or any other building. Therefore, the panel must be grounded with a ground rod as required by NEC 250.32. The homeowner should also ensure that the panel enclosure is properly bonded to the pool bonding system, unless it is part of a listed assembly that does not require additional bonding. This example highlights the importance of understanding the grounding and bonding requirements for electrical equipment near swimming pools. It also shows how the interpretation of the code can vary depending on the specific circumstances. By following the code and consulting with local authorities, homeowners and contractors can ensure that their electrical installations are safe and compliant. Let's delve further into specific grounding scenarios and address potential challenges that may arise during installation or inspection. One common scenario involves determining whether a structure truly qualifies as separate. The code provides a general definition, but real-world situations can be nuanced. Consider a gazebo adjacent to a pool. If the gazebo has its own independent foundation and is not physically attached to the pool structure, it's likely to be considered separate. However, if the gazebo shares a common foundation with the pool deck or is structurally integrated with the pool, it may not be considered separate. The key is to assess the structural independence and the intended use of the structure. Another challenge can arise when dealing with prefabricated pool equipment packages. These packages often include pumps, filters, heaters, and control panels that are mounted on a common skid or platform. The question is whether the entire assembly should be considered a single piece of equipment or whether the individual components should be treated as separate items for grounding purposes. In most cases, the manufacturer's instructions will specify how the assembly should be grounded. If the instructions are unclear, it's best to consult with a manufacturer or a qualified electrical engineer. When installing a ground rod for a separate structure, it's important to follow the requirements outlined in NEC 250.52 and 250.53. The ground rod must be at least 8 feet long and must be driven into the earth to a depth of at least 8 feet. The top of the ground rod must be located below the permanent moisture level of the soil. The grounding electrode conductor, which connects the ground rod to the panel's grounding bus, must be sized according to NEC Table 250.66. In some cases, it may be necessary to install multiple ground rods to achieve the required grounding resistance. The NEC specifies the minimum spacing between ground rods, which is typically 6 feet. When connecting the grounding electrode conductor to the ground rod, it's important to use a listed connector that is suitable for direct burial. The connector should be installed according to the manufacturer's instructions and should be protected from corrosion. If the soil is particularly corrosive, it may be necessary to use a special type of ground rod that is designed to resist corrosion. Another important consideration is the location of underground utilities. Before driving a ground rod, it's essential to contact the local utility companies to locate any underground cables, pipes, or other facilities. Striking an underground utility can be extremely dangerous and can cause serious damage. In addition to grounding the electrical panel, it's also important to ensure that all metal parts of the pool structure are properly bonded. This includes the reinforcing steel in the pool shell, the metal piping, and any metal equipment associated with the pool, such as pumps, filters, and heaters. The bonding conductors must be sized according to NEC 680.26 and must be connected to a common bonding grid. The bonding grid should be located around the perimeter of the pool and should be connected to the grounding electrode system. When bonding metal parts of the pool structure, it's important to use listed connectors that are suitable for wet locations. The connectors should be installed according to the manufacturer's instructions and should be protected from corrosion. If the pool has a vinyl liner, it's important to bond the metal parts of the pool structure to the bonding grid before installing the liner. This will help to prevent electrical shock if the liner is damaged or punctured. Another important consideration is the use of ground fault circuit interrupter protection. As mentioned earlier, ground fault circuit interrupters are required for all receptacles located near the pool, as well as for any receptacles that serve pool equipment. Ground fault circuit interrupters are designed to detect small ground faults and quickly trip the circuit, preventing electrical shock. It's important to test ground fault circuit interrupters regularly to ensure that they are functioning properly. The NEC requires that ground fault circuit interrupters be tested at least once a month. In addition to ground fault circuit interrupters, it's also important to use other electrical safety devices such as arc fault circuit interrupters and surge protectors. Arc fault circuit interrupters are designed to detect electrical arcs, which can cause fires. Surge protectors are designed to protect electrical equipment from voltage surges, which can damage or destroy sensitive electronics. By using a combination of grounding, bonding, ground fault circuit interrupters, arc fault circuit interrupters, and surge protectors, it's possible to create a safe and reliable electrical system for a swimming pool. These are just a few examples of the many grounding and bonding challenges that can arise in the context of swimming pools. By understanding the code requirements, consulting with local authorities, and following the manufacturer's instructions, it's possible to overcome these challenges and ensure that all electrical installations are safe and compliant. Always prioritize safety and seek expert advice when in doubt.